Welcome to the fascinating world of calculus. Today, we explore integration, a powerful tool used to measure the accumulation of quantities over time. In basic geometry, finding the area of a square or a triangle is easy. We simply apply a standard formula to straight lines. But what happens when the lines aren't straight? Imagine trying to find the exact area under a smooth, sweeping curve like y equals x squared. Traditional formulas fail us here. This is the fundamental problem that led mathematicians to develop the concept of the definite integral. To solve this, we use a clever approximation. We start by filling the space under the curve with several wide rectangles. By summing the areas of these rectangles, we get a rough estimate. However, there is still too much empty space or overlap. This method is known as the Riemann sum. As we make the rectangles thinner and more numerous, the approximation becomes much more accurate. Imagine the width of these rectangles approaching zero. At this limit, the sum of their areas becomes the exact area under the curve. This transition from a discrete sum to a continuous limit is symbolized by the elegant integral sign, derived from an elongated s. Integration isn't just for abstract graphs. It describes the real world. Consider an object moving with a velocity that changes over time. If we plot this velocity on a graph, the area under the curve represents the total distance the object has traveled. By integrating the velocity function from the start time to the end time, we calculate the exact displacement with mathematical precision. Another example is filling a container. If the rate of water flow changes, we can use integration to find the total volume. Even if the container has a complex, non-uniform shape, integration allows us to sum up infinitely small horizontal slices to find the volume. These applications are vital in fields like engineering and physics, where we often deal with systems that are constantly in flux. Now it's your turn to try. Consider a function where f of x equals 3x squared. Can you find the area from 0 to 2? Pause the video and take a moment to solve it using the power rule for integrals. Remember to evaluate at the upper and lower bounds. The solution lies in the fundamental theorem of calculus, which links the concepts of derivatives and integrals into one unified theory. Essentially, integration is the reverse of differentiation. It allows us to rebuild a function if we only know its rate of change, from predicting economic trends to launching satellites into orbit. Integration provides the mathematical foundation for modern innovation. Thank you for joining this Introduction to Integration. Keep practicing, and you will soon master the language of the universe.